Okay, first task in number 22 is to factor. So let's do that. Let's see, x squared plus 7x plus 12, that's another 3 and 4. Okay, so x plus 3, x plus 4. I know I just reversed the order. Relax. Okay, so if I take each one, set it equal to 0, and solve, I get x equals -4 and -3. Okay, so I need to make a number line. And I need to label that. And let's see, so I need to pick some sort of test numbers that I can manipulate. And I'll just use 0, that's always easy. Okay, and again, all I'm interested in is positives versus negatives. So if I do -5, so -5 plus 4, that's negative. -5 plus 3 is negative, and a negative times a negative is a positive. -3.5 plus 4 is positive. -3.5 plus 3 is negative, and if I multiply a positive and a negative, I always get a negative. And 0, I get a positive, which gives me a positive result always, always, always. All right, according to the symbol, I'm looking at less than or equal to 0. So the solution for this inequality would be where the negatives live. So that would be bracket from -4 to -3. Okay, number 23. Okay, this is a rational inequality. We want to set the numerator equal to 0 and a denominator equal to 0 and solve. So we end up getting +5 from the numerator and -3 from the denominator. And okay, so exact same little trick from last time, except we'll test point it. So something less than -3, like -4, something between -3 and 0, something bigger than 5, like 6. Alright, so -4 minus 5 is negative over a negative, which is a positive result. 0 minus 5, so a negative, and 0 plus 3 is positive, which always gives me negative. And then 6, so 6 minus 5 is positive over a positive, which gives me a positive. Okay, so this time we're looking at the greater than or equal to 0. So that would be up till -3 and then after 5. Okay, so the symbol says bracket, but the question I want you to think about before I write it, can I put brackets on both? Because the answer is actually no. In a rational inequality, anything that came from the denominator can never be bracketed. So the 5 is fine, but that -3 has to be a parentheses. I cannot include a -3 as a solution simply because -3 would be kicked out of the domain of that particular rational function. So there's your answer on that one. All right, number 24, I'm just writing this polynomial out in its factored form. So it's going to look like p of x equals, then I'll just take each of my factors, move it over, and write it out. So x equals 2 means it's going to look like x minus 2. X equals -2 will look like x plus 2. Let's see, I plus 1 will be x minus I minus 1. And since it is fourth degree, there's another 0 that wasn't written down, but is connected to this I plus 1. And that involves the conjugate. So if I plus 1 is a 0 of the polynomial, then I minus 1 also has to be a 0 of the polynomial. So the other factored form is x minus I plus 1. Okay, and that right there is a perfectly fine answer. I even wrote a sentence: do not multiply the factors. Leave it in factored form. Anyways, so just follow directions and you'll get through this question pretty quickly. All right, so this last question, and this typically is the most time-consuming question, simply because of all the steps involved to get it right. So just be aware. Don't do this to the very end. Answer all questions first. Wherever you are, stop what you're doing. I want you to nod and acknowledge this. This is the last question you attempt, and you put it off to the very end, simply because it will take you the longest, and you don't want to burn your brain out on other things, or you don't want to burn your brain on this one and then mess up everything else. Okay, possible rational zeros. I'm going to look at the last number and the first number. I'm going to make a list. So for the number 45, and I know it says minus, but relax, because we're going to plus minus our list anyways. All right, the numbers that go into 45 are 1 and 45, 2 doesn't, 3 does, so 3 and 15, 4 does not, 5 does, so 5 and 9, 6 does not, 7 does not, 8 does not. Okay, so we got our whole list. And then we got, for 2, it's just 1 and 2. Okay. So our possible rational zeros, I'm going to take everything from the 45 list divided by everything by the 2 list. So 1 over 1 gives me 1. Let's see. I'm just going to try to put them in order here. 3 over 1. Let's just leave it like it is. So 45 over 1. 3 over 1, 15 over 1, 5 over 1, 9 over 1. Okay. And then I want to go back and do the same numerators, but now I want to put the denominators as 2, and that's going to pick up some numbers in my list. So 1 over 2 is new. 45 over 2 is new. 3 over 2 is new. 15 over 2 is a new number for me. 5 over 2 and 9 over 2. So I've got a very, very long list to pick from here. So what is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So actually I have 12 times 2 because pluses or minuses. I've got 24 possibilities for this. The one on the test is nicer than this, so please don't stress out too much on this. About the only shortcut, if there is a shortcut that we have, is Descartes' rule of sign. So I'm just going to take a second and look and see if that actually saves me any effort. So I'm looking at positive to negative switches. So from positive 2 to negative, so there's a sign change. Negative 11 to negative 13 stays the same. Negative to positive, alright, so I got a sign change there. And positive to negative, I got a sign change there. Okay, so I have 3 sign changes. So that means I could have 3 or 1 positive roots. Okay, that actually might be worth it if I want to try to look at the negative list. Let me do that real quick. So now I want p of negative x. So 2 to the negative x to the 4th minus 11 times negative x cubed minus 13 times negative x squared plus 99 times negative x minus 45. Okay, so I'll just simplify this where I can. To the 4th is going to stay positive. Negative to the 4th power is, it's not there anymore. It's still a positive number. The cubed, however, this one thing becomes negative, so we do get a negative times a negative, so we get a plus 11x cubed. That negative x squared becomes positive, so that minus in front of the 13 still stays there. Minus 99x minus 45. Okay. Alright, so sign changes, I get 1, which tells me there's 1 negative root. Okay. Now, why did that matter? Well, I know at best I'm going to get one negative root. So if I'm guessing numbers, I'm not going to guess negatives. I've got a stronger likelihood of getting something positive to work out for me, so that's probably worth my time, more worth my time to hang out with the positive numbers than it is the negatives. All right, so let me make my synthetic division setup. Let's see, so I need x to the fourth, x cubed, x squared, x and a constant, 2, negative 11, negative 13, 99, and negative 45. Okay, and I said we're going to hang out with the positives here for a while, so let's do that. So let's see, of my lists, I'm kind of lazy. I'm going to start with positive 1, and then I'll go to positive 3, and then we'll see what we got from there. So I'm going to try 1. Let's see, drop the 2, multiply, gives me negative 9, multiply, gives me negative 22, multiply, and I get, what is that, 77? Okay, so obviously the 1 did not pan out for us. So I'm going to make a little list of things I've tried. 1 was not effective. So then I'm going to go on to 3. Okay, so from the 3, drop the 2, multiply, I get 6. Negative 11 times, negative 11 plus 6 is negative 5. And then that'd be 3 times negative 5 is negative 15, is negative 28. That's looking better. Alright, so then we want 28 times 3, which is negative 84. So 99 minus 84 is 15. Oop, there's hope. 3 times 15 is 45. There we go. So we got one. One of our zeros happens to be a 3. Alright, so this would translate into 2x cubed minus 5x squared minus 28x plus 15. That's nice and lovely. Alright, since 3 worked, I'm curious if 3 will work again. I already know 1 doesn't work, so there's no sense in keeping going back to the 1. As a matter of fact, if you look at our list got smaller, because now we're dealing with just 15 instead of the original 45, right? So if I go back up here, of my original possible numbers, now I'm only looking at things that involve 15 instead of the 45. So things like 45 is no longer going to be an option. 3 and 5 is an option, but no, and 15 is an option, but not 9 anymore. So I just eliminated 45 and 9 from this big giant list of possibilities. So that's nice. That actually was very helpful that I stopped and noticed that. Alright, so let's try 3 again. See if it works. So 3 times 2 is 6. That's 1. That's 3. That would be negative 25, which is, okay, so clearly that's not going to work. Okay, so we tried 3, it didn't work. Okay, so let's go back up to our list again. Let's see, maybe we want to try 5 next. I am guessing, so I'm sort of guessing. I'm going to try, because there is one negative number, I'm going to try negative 3. Let me try that. Let me see if there's a little irony in this problem. Positive 3 don't work. Let's try negative 3. Alright, so let's drop the 2. Gives me negative 6. So negative 11. That's positive 33. Which is 5. Ooh, look at that. Okay. So negative 3 worked. Yay. Okay, now at this point, and that was a guess, by the way. That was just well, I say that as a guess, but I wanted to speed this process up. Alright, so now we're looking at 2x squared minus 11x plus 5, right? Now it's down to quadratic, so now we can just focus in on factoring techniques. So I know it's got to be 2x and x. It's got to be a 5 somewhere and a 1. So let's see, is that going to be sufficient? So 2x times x is 2x squared. 2x times 5 is 10. And 1 times x is 1. And 10 and 1, aha. If I make those both negative, that will work. Oh, looky there, I could have tried 5. Okay. So my other two solutions then would be 5 and 1/2 for something like this. Okay, and then notice we do have 3 positive roots and we have 1 negative, just like Descartes showed this. So that's kind of nice. Anyways, as emphasized, make sure this is the last question you do, since it can be frustrating and time-consuming. Anywho, good luck.